Now, the last topic we have under Graham's law of diffusion is that we want to compare, we want to start certain calculation now, where they will tell you, they will talk about two gases. They will talk about, they want to compare the rate at which two gases are spreading. And in that place now, we want to derive 4 equations that we are going to be using. So at first, considering two gases, which are gas what? A and what? And gas B. We want to consider two gases. The first gas is called gas A, while the second gas is called what? It's called gas B. Now, what is the rate of diffusion? That side now. Now, of gas A, the rate is what? Is equal to 1 over square root of what? Density of gas what? Gas A. That will represent rate of diffusion of gas A. This arrow now means what? Rate of diffusion of gas A. Why this D means what? Density of what? Gas A. Am I talking to you? Yes. Now, if that is it, I can call this one equation 1. Then, do you know that we can simply write this one as rate of gas A is equal to 1 over square root of molar mass of gas A. Am I correct? You have said that rate of diffusion of a gas is inversely proportional to the square root of density. Or rate of diffusion of a gas is inversely proportional to the square root of the relative molecular mass of that gas. Are we together now? Because it is when you get the molar mass and divide it by 2, you get what? Density, vapor density. Are we together now? So, this one or this one is what? Equation 1. Now, for gas B now, we can say we have rate of diffusion of gas B is equal to 1 over square root of what? Density of gas B. Or rate of diffusion of gas B is equal to 1 over square root of what? Density of gas B. Let's call this one equation what? 2. Now what do we want to do now? Dividing. Okay, molar mass. Thank you for that. So rate of diffusion of gas B is 1 over square root of molar mass of gas B. Now let's want to dividing equations 1 by equation 2. We want to use equation 1 to divide equation 2. I mean, divide equation 1, use equation 2. Now, let's go. Let's come to this place. A. We have what? Rate of diffusion of A. Are you watching? Over rate of diffusion of gas B is equal to, what is this? 1 over square root of what? Density of A, Abi, divided by, what was the rate of diffusion of B? 1 over square root of density of B. Are we together? Now, see what I want to do now. To make this area very easy for me, I will repeat what I have here. Rate of diffusion of A over what? Rate of diffusion of B is equal to, in mathematics, I can change this one. I have 1 over square root of density of A divided, I want to change this one now to division sign. It's okay now. So I'm changing this one now to what? This sign, Abby. This sign, which is what? Here now, we have what? 1 over square root of what? dB. Are we together? I rewrite this one as RA over RB is equal to, I rewrite this one 1 over square root of dA. I will change this sign to what? Sign. Then this one will go up, this one will come down. And now square root of dB over 1. Are we there? Now I rewrite this one RA over RB is equal to, now this one, everything here times 1 is that in Abi? Square root of dB over 1 times this one. Square root of what? dA. Now, have you done sort before in further math? In short, I can remove this square root and put a long square root. Am I correct? So I can have RA over RB is equal to long square root of DB over what? DA. This is a formula in a calculation. Out of the 4 formula we have, are we together? Now, I have divided density formula of gas A with density formula of gas B. Abi? Now, let me use molar mass formula now. Molar mass formula now. What am I doing? I'm coming here now. RA over, which is, we have molar mass, Abi, over, where is the second one? RB, that has molar mass, Abi. RB, what is in the front of this one? 1 over square root of what? NA, Abi. Everything now over, what's it? 1 over square root of what? NB. Are we still together? Now, I can have RA, which is this one, over RB, is equal to, I rewrite what is up here. 1 over square root of NA. I change this sign now to what? Divided by what? What is here? 1 over square root of NB. Am I still talking to you?
Yes,
now, RA, I want to rewrite this one back. Over RB is equal to, rewrite this one. 1 over square root of NA. Then change this sign to what? Times. Let this one go up, let this one come down.
Square root of NB over 1.
NB over what? 1. So my RA over RB will now be equal to 1 times this one. NB over N what? A. Now I can change this one to solve. I have RA over RB is equal to I have NB over NA. This is another formula here. Now in the two formula, I'm coming. In the two formula, you will see that A is numerator here, Abi. But here, what happened to A? The denominator is down. B is down here. What happens to B here is up here. Are we together now? Then the same thing here. A is up here. A is down inside the square root, Abi. B is down here, is up here. Are we together now? Take note. Then the third formula now. Do you know that since the rate of diffusion of a gas, I want to make one statement here, is inversely proportional to time. Don't be passing in front of camera like that now.
It's okay.
Now, since, do you know, look at who doesn't understand this statement? There is one Yoruba adage. That Yoruba adage, I will say it in Yoruba, then interpret it in English. It will say, Tegubanle koma roju. Nítorí pé tó bó ṣe ń rẹ ara ayé náà ló ṣe ń rẹ ara ọ̀run. Do you know what it means? He said, if masquerade is pursuing you, he said, endure. Because as the masquerade gets tired, as human being gets tired, so also masquerade gets tired. Am I talking? If you are enduring, you are running, you are tired of what you are enduring. The masquerade is also what? Getting tired. A time is coming when the masquerade says, idiot, waka. You want to kill me, I cannot run again. Is that not it? The same thing here. When we say something is inversely proportional to something, we say as this one is increasing, the other one is what? Reducing. So if we say the rate of diffusion of a gas is inversely proportional to time, we say as time is increasing, the gas that is moving will be getting tired. The way at the speed will be what? Reduced. Am I talking now? So when I say the rate at which a gas will diffuse is inversely proportional to time, it means as the time progresses, in the speed, the gas as it's running is going to reduce in its what? Speed. Am I talking to you? So if that is the case, we can come back to derive another equation here. We can say, okay, now we can say rate is inversely proportional to time. Rate is equal to 1 over time, Abi? So for the two gases, we can say rate of gas A is equal to 1 over time for gas A. Am I correct?
Yes.
And also rate for gas B is equal to 1 over time for gas B to diffuse. Are we together? Are we there? Yes. Eh? No, leave K. We don't use K in this one. We don't use K here. Now, look at this. Am I still on the way? Yes. Now let's go back to these two equations we derived. Let's come back here. Anywhere we see RA, what are we going to put? 1 over time for A. Anywhere we see RB here, what do we put? 1 over. So let's go back now. So what to substitute? Substitute 1 over TA for what? For RA. So let me call this one equation what now?
2.
No, we already have equation T there, B. And let me call this one now equation what? 4. And 1 over what? TB for what? For RB in equation what? Equation 3 and what? And 4. So what is equation 3? I have RA over RB, which is this, is equal to what? Square root of what? DB over what? DA. Am I still correct? This one was equation 3. Is that so? Now, so let me load my this thing with this thing. Inside this equation, anywhere I see RA, I put what? 1 over TA, Abby? Divided by anywhere I see RB, 1 over TB Joshua. Is equal to I see have what? DB over what? DA. Are we there? Then let's resolve this one mathematically. Let's write this one first. 1 over TA. This sign is what? Divided by what? 1 over what? TB. Am I correct? Then it's equal to, let's rewrite what we have there. DB over what? DA. Are we there? Then let's change this sign. Abi? Let's rewrite this one first. 1 over TA times TB over what? Over 1. Then equal to what? DB over what? DA. Are we together? This one times 1 is what? TB over what? TA, Abi? Is equal to square root of what? DB over TA. This is another formula. In this one now, when I'm using time, what is off is off here. B is off. B is off. Are we there? A is down. A is also down. When you are using rate formula, what is up here will be down here. What is down here will be up here. But when you are using time formula, what is up will be up. What is down will be what? Down. So if I call this one now equation what now? Equation 5, Abi. Now we want to derive it now. We say this. Now let's go to equation 4. In equation 4, we have RA over what? RB is equal to what? Square root of what? NB, Abi, over what? NA. Are we still together? Now this was equation 4. Anywhere I see RA, what do I put? I put 1 over what? TA, Abi. 1 over TA over 1 over TB Joshua is equal to, we write as MB over NA, Abi. Now, come back here. I can have 1 over TA divided by what? 1 over what? TB is equal to what? Square root of what? MB over what? NA, Abi. Then let's change this sign. 1 over TA times TB over 1 equal to square root of MB over what? NA. This one times this one, I have TB over TA equal to square root of MB over NA. This is the fourth formula. Yes, we are done now. Now, these are the 4 formula you need to memorize. In this formula you have B is up, B is up. A is down, A is down. Let's now look at how we can solve. Let's look at problem now. Example 1. They say 60 centimeter cube of oxygen diffuses in 5 seconds. Now, in a porous plug. Now, how long would it take methane? Will it take equal volume? This one is very important. Equal volume of methane to diffuse through the same plug? Question mark. Then they will give you. Okay? Methane is what? CH4. So they will give you all you need. Oxygen is what? 16. Then C is 12, Abby. H is what? 1. Yeah, they give you a question like this. So I want to learn how we can use want to use method 1 now. Method 1. We want to use rate formula method. In method 2, we use time formula method. Now, what do we do? First thing to do is identify the gases that are the 2 gases in the question. The first one will represent gas A. The second gas will represent what? Gas B. What are the 2 gases inside this question? Oxygen and what? Methane, Abi. Oxygen will represent gas A. Methane will represent gas B. What do we do? Now, you will say rate of, instead of A now, I would like to oxygen. Are we there now? O2 over rate of the second one is what? CH4 is equal to square root. What is down here will now be up here, Abi. Which one do you like? Do you like molar mass or density? Molar mass is better, straightforward. In density, you find molar mass and now be divided by 2. That will take your time, Abi. Yeah. So let's go. Molar mass of what? CH4 over molar mass of what? Finish. Now it's just to substitute. But if I were you, not to cause problem, there is nothing like time here. And they say, how long? What does how long mean? How long will you are working this morning? How long means time. Find the time. Find the time that it will take what? Methane that has the same volume, which is also 60. Am I talking equal volume? How long would it take equal volume of methane? That is methane, that its volume is also what? 60 centimeter cube to diffuse. But there is nothing like time here. Is there anything like time here? No. Is there anything like time? No. And what is rate of diffusion? Volume over time. Do you still remember? I will now, okay, first of all solve this one. First of all say, okay, the rate of oxygen is equal to what? Volume of oxygen over time for oxygen to diffuse. Are we together now? Now, what is the volume of oxygen here? 60 centimeters of oxygen. What is the time? 5. Divide it now. Now, what is the unit here? Centimeter cube. Unit here is what? Seconds, Abi. So divide now. 60 over 5 is what? 12. That's 12. The unit will now be what? Centimeter cube per what? Now put seconds raised to the power minus 1. Are we there? That's per, or you put slash seconds. Are we together now? So that you will now later put this one in place of what? RO2. Abi?
Yeah. Is there need to put this RO2?
Which one? Here.
Yeah, is there need to put it? Not just borrow it.
They don't give us rates now. They did not say, if the person has said, if because I said 12 centimeter cube per seconds of oxygen diffuses in a porous plug. What are we going to put? Instead of R2, we don't put the 12. R means rate of diffusion, which is we got it now to be 12. Abi? And even the question says, he did not put this 60 centimeter cube. He just say 12 centimeter cube per seconds of oxygen. That one replace this one. Yes.
Everybody is asking how MC is
Which one? Which one? And in the last class, I taught you now rate of diffusion as a subtopic. And I told you that rate of diffusion is what looks like speed. Speed is what? Distance over time. Did I not tell you? I not tell you in gas we don't have distance. What represents distance is volume. Abi? And the reason is that if you want to calculate the speed of human being moving on the ground, you take a tape rule. Maybe you want to, the person run from here to admin block. You want to measure the speed of that person. You take a clock, Abi? Okay, the person runs there, you are watching the time. So when the person gets to that place, you don't measure, take a tape rule to measure from here to admin. That is the distance covered, Abi? Then over the time you used to cover that distance. Are we there now? If you cover that distance in 5 minutes, in 5 seconds, we say, and the distance is 60 meters, Abi? You say 60 divided by the time, that 5 seconds. Answer is what? 30, and that's a 12 meters per second. His speed is what? In every second now, it can cover 12 meters. That's the speed. Another person that covered the same 12 meters, I mean, maybe he not take the person, but he used what? 5 seconds, I mean. Another person that uses 2 seconds. Which person has higher speed? The person that uses 2 seconds, he covered the same distance in the shortest time. Are we together now? That is speed. But in gas, we don't use distance. Do you know why? When human being want to run, as we are living, we used to remain there. But if gas is spreading, part of the gas, is it all the gas that will be moving at the same time? It's spreading. Part of it is still here. Part of it will still be here. Part of you still leave some behind. Are you getting it down? So it's not leaving that spot. So therefore, we are using distance. We are using volume. Volume is the space, the size of the space occupied by what? By gas. Are you getting it now? So we are now, that's why we are using volume over time. So rate of diffusion is what? It is speed that the gas we use to move, to diffuse. Diffuse means what? Movement of a molecule of the substance from region of what? Higher concentration to the region of lower concentration. Movement, the speed of the gas. Are we there? That's volume over time. Are you getting it now? So this arrow oxygen represents the speed of oxygen. That is the rate of diffusion of oxygen. Now, since they are asking us for time, how long? I think the question says 12 centimeter cube per seconds of oxygen diffuses in a porous plug. They did not give us this one again. What is the rate of diffusion of methane? It's not to put the 12 here and make this one the total of the formula. That's the rate of diffusion of what? Methane. Is that the question they ask us? No. They are asking us now, what is the time? So we need to convert this one to a formula that will contain time inside. So that we can also convert this one to another formula that will contain time. I will now make the time here now the subject of the word formula. Are we together here now? Yes. So you understand we got this one now, Abi? Yes. Now we can also rate for what now? CH4. If you go to volume for what? CH4 over time for CH. What are we looking for? Is it not time for CH4 we are looking for? Yes. Are we together now? Yes. Okay. We now come back here now. We now say rate for CH4 now is equal to what is the volume of CH4? They say equal volume. How long would it take equal volume of methane? That is methane that will have the same volume as what? Oxygen, which is also what? 60. So we now have what? What do we have now? We now have 60 over, we don't know the time. That's what we are looking for. Are we together now? So we now want to substitute this 12. Come back to this equation. Anywhere we see rate of oxygen, we put what? 12. And anywhere we see rate of CH4, we put 60 over time for CH4. Are we together now?
Yes.
Now, let's come here now. Now let's come back here. Now let's now substitute. So now the formula, the thing is R what? O2 over RCH4 is equal to square root of what? MCH4 over M what? O2. Are we together? Anywhere we see R this way, we have calculated this 12. Have you? Then over, that's a number 60 over what? Time for CH4 to diffuse. Are we there now? Then is equal to, now what is the molar mass here? Carbon, we have been giving C equals to what? C equals to 12. H equals to 1. O equals to 16. I have crammed it like that. So anywhere I see carbon, I put what? 12. Plus what? Hydrogen is what? 1. And how many hydrogen atoms do we have here? 1 times 4, Abi. Now over molar mass oxygen is what? What's oxygen there? And how many do you have here?
16 times 2.
Now because 16 times what? 2. Are we together now?
Yes.
Now let's do this one in the normal way again. 12 divided by Abi 60 over time for CH4 Abi.
Yes.
Then equals to square root of 1 times 4. 4 plus 12
16.
over 16 times 2.
32.
32. You can say 16 here 1, 16 here what? No wahala. Now, what do we now do? See, we have 12 times, this one comes up. TCH4 over 60 Abi is equal to square root of 1. Good. 12 times this one will be 12 what? TCH4 over 60 equals to, now, square root of what? 1. Now, I want to remove this square root. Are we there? What do we do? Square both sides. We now have 12 square TCH4 square over 60 square is equal to everything here 1 over 2 all square. Are we there? So this square will now cancel out this square root now, Abi. Oh yeah, press your calculator. What is 12 times 12? 12 square is 144, yes. 144 TCH4 square. Oh yeah, 60 times 60. 3600, Abi. Now, we don't have this square root again. We now have 1 over 2. Are we there now? We can cross multiply now, Abi. So we now have 144 times 2. 288. TCH4 square, Abi. Equal to 360. 3,600 times 1. 3,600. So we divide both sides, Abi. So we have TCH4 square equal to 3600 divided by what? 28. We have press your calculator now.
12.5.
Eh?
12.5.
Okay. 12.5, Abi.
Yes.
So we have 12.5. Now, but don't forget, there's a square here. We are looking for time for CH4 to diffuse. But we have a power here. Eh? So let's write it now. TCH4 square equal to 12.5. So what do we do to clear this one? Take square root of both sides. Abi? TCH4 square equal to square root of what? 12.5. So this one cancel this. Time for CH4 to diffuse. What is square root of
3.54.
Eh?
3.54.
3.54 seconds. Method 2.